Good morning, good evening, good afternoon, everyone, wherever you are. Welcome to this episode of the OpenStack Unlocked podcast. Today we have with us Alex Polvi, the CEO of CoreOS. Hello, Alex. Thank you so much for joining us.
Hello. Thank you for having me.
Thank you. And of course, I am Nick Chase, and we have also my illustrious co-host, John Jainschigg. So good afternoon, everyone. And today we're going to be talking about containers. I'm sure that those of you who are in the OpenStack world have never heard of them before, and this is going to be a strange topic. And you're just going to be so surprised that we're talking about containers. Yes, that's sarcasm. So let's kind of start with a little bit of background. Alex, you want to tell us a little bit about where you guys are coming from and kind of how you wound up in this position? Because you'll notice at no time did I say the word Docker in this conversation. So until then. So please go ahead and tell us kind of where we stand.
Sure. So we started CoreOS about 3 years ago now. And when we started the company and still today, our goal is to fundamentally improve the security of the internet. And we believe that the key to security in a big way, at least in current state of affairs, is around updates. And the ability for a company to just update their infrastructure and their software. And so as we go to solve that problem, what's keeping people from keeping their infrastructure up to date? Well, it's the fact that the way companies run their data center today is quite fragile. I mean, the mantra is get it running and don't touch it. So then we looked at, okay, how can we solve that? And the way to truly solve all of this, to build infrastructure that's both robust and serviceable, is to look at what's happened with the hyperscale guys. And the hyperscale guys have built their servers and their data centers in a pretty distinctly different way than pretty much every other company out there. And it involves a lot of distributed systems. It involves containers. It involves commodity hardware, kind of all of these attributes. We call it GIFY, or Google's infrastructure for everyone else. And we want that style of infrastructure to exist. It has a bunch of benefits all on its own, but we also think we can use that infrastructure to dramatically improve the security of companies' data centers and thus the internet at large. So that's kind of the big picture about why we got going with what we were going on.
Okay. So now when it comes to containers, I mean, what is the general advantage? I mean, we just kind of do the level set here before we go deep in.
Yeah, the main thing is really thinking about your data center in terms of applications instead of as servers. And it's that one kind of click up the stack towards application focus, deployment and management is a big key. That's what allows us to bring in the distributed systems. It's what allows you to, do introspection of containers for vulnerabilities. It's what allows us to, automatically patch and update lots of the systems for you. It allows you to pull the plug on any server at any time and keep things running. It allows you to get much higher utilization. It allows you to have a consistent environment between cloud and your physical data center, and all of these things. So it's that application-focused nature of a container, which is kind of the big part of this.
Okay. And how does that relate to, say, OpenStack?
Sure. So OpenStack is a couple things. One, I look at OpenStack as an application. It happens to be an application that provides a set of APIs, and the primary use case for it are APIs to generate virtual machines. That's kind of the big one. And who is that useful for? Like, who needs APIs for creating virtual machines? There's public cloud service providers is probably the biggest one. AWS really created this model, and Rackspace created OpenStack because of their own needs for building APIs that generate virtual machines. And then there's companies that are just so big that they want to run their own environment that way. So one is about, what are tools, software-driven ways to give you compute. The other piece, the stuff that we're focused on, is how do we consume that compute? How do our applications consume that compute, and how is it managed? And they're a bit I think, are a bit orthogonal in terms of how they're used. And OpenStack in and of itself, I think of much more as an application. Has a database, and it has web APIs, and somewhere in there it fork execs a VM. That's kind of what happens deep down. And you still need systems for getting that software deployed and updated and everything, just like any other application.
Okay, John?
So that's interesting. I mean, you see CoreOS then as the infrastructure picture for something like OpenStack, were it possible, and of course now it is with Cola, to run OpenStack components inside containers, that seems perfectly reasonable. It intrigues me that you began with security as a brief here, because security is the kind of thing that that many enterprises, obviously, if one reads the newspaper, are not particularly expert in, or are rapidly hiring in expertise to do, but that needs obviously to be done very systematically. But the focus of attention is on developer productivity and IT management productivity through DevOps, more than security per se. And so it interests me that your thinking proceeds from a security framework, but it's obvious that CoreOS is a hugely useful tool for reconceptualizing data centers to be highly productive and software driven, right?
Mm-hmm. Yeah, we built. So again, the logic is secure the internet. Internet requires updates. Updates require serviceable infrastructure. Serviceable infrastructure needs to look like Giphy. So let's make Giphy real by giving a bunch of open source away. And open source is really useful for kind of moving the industry forward. To take the really hard problems and just give them away for free for everyone. And the baseline of what companies are capable of just moves up. Okay. And so the areas where we started contributing open source were, one, our lightweight Linux OS that automatically updates itself and is container based. So you can just forget about like patch management and security updates at the OS level. We built etcd, which is our distributed key value store, which solves the hardest problem in building distributed systems, known as consensus and consensus algorithms. And that then in turn helped make building distributed systems in general easier, and that's where Kubernetes has a hard dependency on etcd to date, for instance, so things like that. So it's kind of that it all falls out of that mission. But because our mission is around security, the things that we do will always be more security focused. So when you look at things like Rocket versus Docker, Rocket is our container runtime. That's, I think, one of the biggest points of where we can articulate the differences in just the way that, these companies and communities think. Containers in the general sense have a lot of different value props and uses. We think one of the huge ones is around security. Docker approaches it for a bunch of different other reasons, and that's perfectly fine. But we think that this way of running infrastructure and containers represent, a big meaningful change for companies that create an opportunity to make things much more secure. And we'll build anything that nobody else is building, build the white space in order to make that happen.
Okay.
So in what ways can containers contribute to security? I mean, they're most frequently spoken of as something that potentially compromises security.
Yeah.
Security.
That's an unfortunate myth of this whole thing, and I think it relates to a particular implementation of containers. They don't need to be less secure. In fact, I think in the default configuration, containers are more secure. And let's just look at first, there's a myth of containers versus VMs, and that these are some competing technologies. Okay, well, if you ever want to trump that, just be like, are containers going to ever run on AWS? Okay, well, AWS happens to be all VM based, and that probably isn't going away anytime soon. So I don't think containers and VMs are mutually exclusive. They will work together for a long time. And then the other thing that relates to is, typically when you're talking about container versus VM security, we're talking about isolation, which is one form of security. Application isolation is one form of security. And yes, it is true that virtualization is a more secure form of isolation than a Linux container is. That is true. But look at what companies were doing before containers. What companies were doing before containers is you boot up a VM and you maybe install 3 or 4 or 5 or 10, applications on that one host. And if that one host gets compromised, there's no walls between those applications. You get one, you pretty much get them all. With a container, at least it puts up one wall around it. It's not a perfect wall. It's a wall that might be locked and has a door in it, but it's you might be able to get through that door. But a VM, is that room with no doors in it at all. So yes, it is slightly more secure. But my point is, before containers, companies weren't isolating per application. The only place where you could get better isolation than a container is if a company was deploying one VM per one app in their data center. which isn't crazy. That happens, but not what happens by and large. Most people boot up a server, use a configuration management system, set up a handful of applications on that one server. And so my argument on an isolation perspective is that containers are actually a step forward. Now, if your implementation of containers doesn't, for instance, do a signature validation when it downloads the content, that could make it less secure. Or if when it talks to the internet or serves an API that's running as root on your server, that could be a problem as well, because that's kind of like operations 101. And that stuff is just unfortunate side effects of an implementation of containers. It has nothing to do with like containers themselves, if that makes sense.
That makes perfect sense. So now Rocket, you just had a new release of Rocket. Can you tell us a little bit about what's new there?
Yeah. So Rocket, by calling it 1.0, this is mainly a API stability release for us. We are saying that APIs, both in terms of the pragmatic APIs, as well as the command line APIs, as well as the on-disk formats, how everything uses, is stable. We won't change it on you without proper deprecation schedules and those sorts of things, and rolling API versions and those sorts of things. So hitting 1.0 means we've stabilized kind of the APIs and on-disk formats and so on. It also means that it's generally been used for a while and people find it production ready and it's stable and it works well. And so the things that the Rocket really focuses on is, one, architecturally being built that it can be more secure. These are things like just borrowing on basic Unix philosophy, things like privilege separation, so that your thing downloading from the internet doesn't have to be running as root on the server. Or trying to build in modern best practices. Like when you execute a container, we automatically wrap everything in SE Linux for you, so you don't have to think about it. It's just set up, ready for you. Or pluggable isolation, so we can actually execute a container inside of a VM transparently for you, where we're building a little OS and kernel and a lightweight hypervisor just around the container. You don't even see it happen, and it all happens in like 300 milliseconds. So you're getting that VM isolation, but it still feels like a container to you. So those are some of the capabilities and things that we focused on, again, from building a very security-minded, focused container runtime.
Now this is the open source project.
Yes, now, Rocket is an independent open source project. You can use it on Fedora or Red Hat or whatever you want.
Now you also have commercial products.
Yes. So
tell us about that and how they relate.
Sure. So our commercial products is that Giphy in a box. Okay, so it's the Cloudera or the vSphere. It's a package of distribution of all the stuff that makes it useful. So the companies that are out there using our open source are typically taking all these components and building their own version of that product, which is called Tectonic. So we have customers that take CoreOS Linux and they take etcd and then they go and build their own Tectonic. And that's perfectly fine. It's like taking some tires and some door handles and then going and building your own car, okay? And if you want to do that, go for it. And we will support you and we will stand behind our door handles and our tires, okay? And if you'd like to, though, we will also sell you Tectonic, which is that complete package. And we think we've done it in a way that is very solid and robust. And we will service it for you as well. And we will make sure it's always up to date and doing kind of the latest and greatest. And so there's a whole class of companies out there that don't want to be in the business of piecing together their own stuff. And that's they can come to Tectonic. So Rocket is part of Tectonic. And the reason it's in there is because it has some unique security capabilities. For instance, like talking to the TPM, which allows us to do things in Tectonic that no other platform like this can do around security. And so it's that combination of CoreOS Linux and Rocket and Kubernetes that allows us to just have some unique capabilities that if you were to go piece it all together yourself with random components, you wouldn't get.
I love that analogy, by the way. I may steal it at some point. I love that analogy, and it so beautifully defines what a lot of people are doing with OpenStack as well. So that is quite lovely. So what are you feeling on this whole cloud native computing initiative?
Yeah, cloud native is another way of saying Giphy. I think nobody wanted to put Giphy or Google in the industry term except us, but it's very similar in spirit. It's cloud. So I'm a governing board member on the Cloud Native Computing Foundation, and what that means, Cloud Native Computing Foundation is the style of application that's dynamically scheduled, container-based, microservices oriented. I think I'm like quoting from the charter right now, but it's it's Giphy. We call it Giphy, but you can call it cloud native if you want, whatever.
Okay, fair enough. Although I may put together a drinking game every time
Uh,
you say Giphy.
yeah, sounds
But
good.
there you
Sounds
go.
good.
Um, okay. Um, and I've completely forgotten what I was going to say next. John, any?
I want to know about how people come to Rocket and CoreOS and Tectonic. Do you find that they have, excessively fooled around with, the Docker toolkit and Kubernetes open source, and have tried piecing, a solution together out of those components before they arrive at Tectonic? And what kind of workflow changes can they expect if they go with the more coherent, commercially supported toolbox?
So you're asking, what is the path to Giphy? that is what you're asking.
Yes, or cloud native.
And what we're seeing customers do with the path to Giphy is starting with the open source pieces and playing with it. I mean, I think one of the first entrants into it is you go build your first container. That's what a lot of people do. I made my container. Cool. I can run it. It does something. I feel really good. Okay, so that is the first step. From there, you need to probably put it in a container registry of some sort. So you need to share it with other developers on your team, or you need to share it with your servers. And the way that you do that is by pushing it to either a hosted registry, or you go and put one on-prem, and so on. So I say first it starts by playing with the components. Then it starts by playing with your registries. And then you start piecing together all the distributed system side, because you need to think about, how do I actually run this in a group of servers? And that's where you start bringing in Kubernetes or Mesos or Swarm, and you start piecing that side together. And then you realize it gets really complicated really quickly, and you're like, maybe I should just work with a vendor on this, because it's actually a lot of different moving pieces. The whole platform in and of itself, and this is for commercial vendors. Obviously, there's lots of companies that have their own engineering resources internally, or they are just hobbyists playing with this, and that's all fair game too. And you can go and set it all up yourself; it's no problem. If you're a business, you're trying to build some business application. You're not trying to become like pros in cluster management. You're trying to just ship some software. And so the faster we can help you do that in a way that doesn't lock you in, it becomes pretty compelling pretty fast. But we see it starting with people making a container of their application, figuring out how to share it, and then figuring out, oh my gosh, I need to deploy it. And then around then is where we start having the Tectonic discussion.
Gotcha. So are there any questions that are there anything that's let's start again. Is there anything that's out there that are just basic misunderstandings that you wish people would just kind of get clear in their heads?
Yes, there are many.
Okay.
Just a few that come to mind. One, this containers replace virtual machines thing. I think that's really confusing for everybody. There's another one that's like legacy apps don't run in these types of environments, which again is a confusing one. There's these things around state, which relates to legacy apps. Like only stateless apps can run, and it's like no. And then that containers are less secure. That's another one that bothers me a lot, and I think it's just holding the industry back in general. So all of those are wrong. They get repeated all the time, but they're just totally wrong, and it is horribly frustrating. So where would you like to dig in?
Well, let's see. We talked about containers and security.
What about legacy apps?
Yeah, let's talk that one.
Okay. Let's start with legacy apps. So before containers, what you had was on a server, a process running on a Linux machine. Okay? That's what your app was. Assuming if we're not talking about, let's just say Linux on the server for now. If we want to open up Windows and stuff, whatever, but Linux on the server. After containers, you have a Linux process running on a server. Exact same result. Okay?
Well,
and I think what gets confusing for folks is there's a spectrum between essentially a person, an operator hand logging into a server and logging in some stuff, and then way over here on the other end of the spectrum, which is like, I don't know, App Engine, or something like that, where you write your business logic function and it goes and executes somewhere out in the cloud, whatever, okay? There's like this huge spectrum. In the spectrum, there's like configuration management. That's essentially that ops guy logging in and SSHing, but like essentially writing it all down in code, okay? Which is right after they put it in the spreadsheet, they like write it down in code, okay?
Yes.
And then over here, there's this other layer just emerging right now, which is this thing we have that's cluster management, container-based, so on, okay, this Giphy style of infrastructure. And I actually think if you think about it as configuration management, so just trend for a moment thinking that direction, it's closer to Chef and Puppet because it's about managing applications. It helps resolve a lot of these conflicts. So if we just think of it as configuration management, with the key difference being there's dynamic placement. The operator does not say which server it runs on. The computer says which server it runs on. If you think about it with that key difference and then be like, okay, can my legacy application run in configuration management? Yeah, probably can. I bet you can make pretty much everything run in configuration management. And so then it's like, how do I make it work with dynamic placement? And the tricky parts, and it kind of relates to storage mainly, is if I dynamically place an application on a server, then my storage has to dynamically appear with it as well. Okay, and that's like the one more sophisticated thing you have to do. So you have to be using a network file system or something that allows you to attach storage kind of anywhere in your cluster if you want to manage state. But that doesn't mean that you can't manage state anymore. It just means like it's different how you go about doing it.
I think that's fair. John?
It makes sense to me.
Anyway, the net result is
clear explanation. Yeah.
One other thing I just want to call out is that like when I think of like legacy enterprise software, and this is not at all like to knock on any companies, but there's these big enterprise software companies that all come to mind. Folks like Oracle and CA and like SAP, these types of companies that come to mind as traditional enterprise software. These guys are all over containers. They're showing up at every event. You'll see them all around. And that's because they see it as a way to do consistent packaging and deployment of their applications, a problem that's plagued them for a long time. And so it's like, again, maybe you can't run Microsoft Word on Linux, but you couldn't do that before containers either. You had to put it in a virtual machine. So that's not really fair, you know.
I think you're right there. So, well, then let's hit the biggie because I've hit this, but we need to hear it coming from you. Mm-hmm. Containers and virtual machines.
Mm-hmm. Okay. Again, the root of my argument is just like everybody's moving to public cloud. Public cloud's going to be based on virtual machines forever. Containers are going to work on virtual machines for a long time. They're not in conflict. You need both. They're just different things. And again, think about, does Puppet replace virtual machines? Does Chef replace virtual machines? Again, thinking about it from that configuration management angle. No, they're just different. One is for like running the stuff. The other one is for how you like describe how to run it and package it up. You know, they're different things. Where it gets confusing and what everybody like gets confused with is that you can run these full kind of OS user lands in your container. So that the environment your application is executing in might feel like it's running in Ubuntu, or it might feel like it's running in Debian, or it might feel like it's running in RHEL. And that's really just like a packaging thing. That's just saying per application, I'm going to bring a whole user land because I've constructed my application in a way that requires, you know, /etc SSL to be in a certain configuration and user lib whatever to be in a certain configuration. That, and my application actually depends on the way that Ubuntu is laid out. So I have to package all of Ubuntu with my application to run it. But the big difference is you're doing a package for per application or per microservice that you want deployed. And that's just where it gets confusing because it feels like you're deploying a full OS because you have that whole Ubuntu user land, but you're not. You're not booting a kernel. You're not running a bootloader. Like, it's not a virtual machine. It is just happens to be a packaging mechanism, which includes a whole nother instance of an OS, which I think we will see trending away from over time because it's much harder to manage security in that environment, and people are starting to realize it. We have this feature in Quay, our container registry, that does security scanning, and we built it because all these people are packaging full distributions inside of their containers, okay? But they're not like checking if their stuff's insecure in the container, okay? And when we ran this, we ran it on initially before we released it on a couple million containers that are on Quay, and we found that over 80%, this is as of like a month ago, still have Heartbleed in them. Like, oh my God. And this is in the container. So it's that full. I think we'll see overall a trend away from that style of packaging because your surface area for vulnerabilities is just so big inside there. And the images get pretty hefty too. They turn into a couple hundred megs pretty quickly, which if you're deploying across 20 servers, that's a lot of bandwidth and blah, blah, blah. It adds up pretty fast.
And kind of defeats the whole purpose.
Right, yeah.
Unquestionably, too, it would be more elegant just to containerize Heartbleed itself.
Yeah, just take it.
Yes, I can't argue with that.
So as people move away from the the user lands that they find comfortable and that they've written to and that they may have dependencies on, what does the eventual user land look like? What is the user land of the future? For what lives inside the container.
Yeah, I think the most logical extreme version you can get to is like Go. So Go is a single compiled binary. Like all Go applications are this statically compiled binary that's really just it. So your Go container is just your binary and that's it. And it's kind of all packaged up into one thing. That's as far as it can go. No pun intended. But that's as far as you can do it. So one click above that would be like a JVM container and then your Java code on top of it. And then beyond that, I think you'll see, some lightweight Linux user lands that allow you to run, most applications. But people are just really comfortable going from Ubuntu, apt-get install Apache 2, and now you have a container with Apache 2. But it's really just a packaging mechanism. So if you think about just the base Docker images as an alternative to like RPM and Deb, I think that's where we'll end back up over time for all the general purpose stuff. And then you'll see these fatter containers for companies that just don't want to spend the time to really package it all up for the same reasons they didn't want to package up their own RPM and Debs for every single application that they built. Which if they did would be the best practice. If every single thing you built, your developers gave you an RPM, the ops guys would love you. But that's just not the way the world works.
All right, fair enough. So I think we're getting towards the end now. So John, before we wrap up, were there any other questions that you wanted to ask, and then I'll ask my final question.
No, I no more questions. But I have to say that my urge to immediately download all of this and throw it up on 8.0 and run it is pretty strong. I've been fooling around with other various other toolkits out there and banging around with Mesos and Swarm and so on. And I feel like this adds a great deal of value to an already strongly valuable and fundamentally simple proposition. I want to feel how easy it is to get up and running on a tectonic environment, and see what happens to me as a developer as a result.
That's a good point. And actually, while we're on the subject, Alex, what is the relationship with Rocket in terms of Magnum and other OpenStack projects?
It's a great question. Rocket's been adopted by all the major cluster management systems. Like Kubernetes supports it, Nomad supports it. I don't anticipate Docker Swarm supporting it, but Mesos, I'm not sure where their support is at. In terms of OpenStack, I honestly just don't know. I haven't looked yet. I wouldn't be surprised if somebody's taking a swing at it, but I haven't looked yet.
Okay, but it's supported by Kubernetes, so any part of OpenStack that supports Kubernetes theoretically
supports Rocket.
Supports Rocket. Okay.
Yeah.
So we'll have to check on that, and we'll get that into the show notes. All right. So traditional last question: are there any questions you wish somebody would ask you?
How would running OpenStack on Kubernetes improve my environment?
How would running OpenStack on Kubernetes improve my environment?
Well, I'm so glad you asked. So one of the biggest things that holds back OpenStack is installation and upgrade. It's a big kind of beast in order to get things upgraded and going. And at the end of the day, if you think about Kubernetes as a alternative to Chef and Puppet, it actually represents a pretty novel, interesting solution for how you could do lifecycle management of the cluster itself. So there's been a lot of thinking of Kubernetes on OpenStack, and that's more just OpenStack as a way of giving you virtual machine compute in order to run your cluster on. to think about it at the other end, which is OpenStack is just an application that needs to be installed and upgraded just like anything else. Could running it on a cluster management system like Kubernetes give you a big lift? And I think, yes, it could. I think it would make it much easier to install and upgrade, and all the primitives built into Kubernetes can make it so you don't have to make too many major changes to OpenStack to do that, but there might be some depending on how things were, which assumptions were made in the platform. So I think nobody's really taken a swing at it yet, but I think a really interesting proposition for the OpenStack community would be think of Kubernetes as a configuration management system. Get it to deploy that way, and on the other end of it, you're going to have an environment that's much easier to maintain.
That's very interesting. John, you're more familiar with the Kala project than I am. Do you see a relationship there?
Oh, I would think so. I mean, right now they're focused, I believe, on the Docker format, but I think they're changing.
Well,
making other formats
shouldn't matter. Yeah.
There's a couple of pieces. There's packaging, which is what Kala is doing. They're just putting the OpenStack components in a container, and then you have to deploy, which is the Kubernetes side of it.
All right. Very interesting. Fascinating question, Alex. I'm so glad I asked. Anyway, all right. So I think we are now at the end. So I just wanted to thank Alex Polvi, CEO of CoreOS, for spending your time with us today. We know that you're really, really busy, especially considering that it's taken 5 months for us to make this work. So, and also thank you very much, John. I know you're very busy with the upcoming Mirantis OpenStack 8.0 release. And so until next time, thank you all very much for spending your time with us, and we'll see you next time.
All right. Thank you so much. Bye.
Bye.